Hello. Hi, how's it going? So a lot of people in here know me. If you don't know me in person, chances are pretty good that I have said either very kind or horribly rude things about your pull request. I am cashed out on GitHub and Twitter and all of those things. I get the good fortune of interacting with many of you online, and as I always try to do when I get a chance to speak at SaltConf or anywhere else, the first thing I want to do is thank you so much for all of your work that you do on Salt. Sometimes we don't thank you as much as we should, and it's important to recognize that open source is, at the end of the day, a volunteer community. It's a self-interested volunteer community, and that's great, but it's a volunteer community, and honestly, thank you so much for the work that you do. It's really appreciated by me. So often, I get assigned to fix a bug, and I put it off, and then I come in the next day, and one of you have done it, and that totally makes my day. So thank you for all of the work that you do. It's really, really appreciated. So I'm the senior core engineer at Salt. I work on primarily core engineering problems, which means I don't actually get out into the space of this talk all that much, because typically I'm working on like transport or pillar or things of that nature. But there are many, many interesting places in Salt, and a lot of them are not platform specific, and so that's sort of what I want to talk about today. Places inside various plugin systems that are related to the management or understanding of Salt itself as a system. So what we're going to do first is we're going to go over the various plugin systems. We're going to talk about beacons, we're going to talk about reactors. When I wrote this talk originally last year, that stuff was all brand new. Unfortunately, not as many people as I would like are familiar with those systems, because people generally treat Salt as a configuration management platform, and while it very much is that, I think that is only 10% of the story of Salt, and so I would very much encourage people to think of Salt as much more than that. I consider it to be a general automation framework for systems management. So in terms of the top secret, as it were, right? I didn't create the title of this talk, by the way, and I dislike it intensely. The so-called top secret plugins, we're going to talk about SDB, we're going to talk about SaltMod, we're going to talk about test.state, SaltUtil, and then poke around a little bit in state.py. So the first thing to do is to talk about Salt as a fundamentally modular system. Now, most people realize that this is true. Salt's core is, in effect, very, very small. I would be willing to bet that the sum total probably of Salt's core architecture in terms of areas which are not fundamentally a pluggable system, probably excluding utils, is probably less than 5,000 to 7,000 lines of code. Thane would know, right? Like it's in that neighborhood. It's not a ton. It's not what you would expect. For a nearly 400,000 line code base, almost all of it is a pluggable system, right? This is all made possible by the Salt loader. If we do have time today, we may take a peek at the Salt loader. One of the things that I would sort of like to do toward the end of this talk is to give you a sample of, or an example of how easy it is to make a new pluggable system in Salt, right? One of the points that Tom Hatch made the other day when he and I were teaching the advanced class was that Salt's loader, right? And the loader is this piece of code, and that can take basically directories of Python modules and sort of abstract them into kind of a virtualized namespace, right? For us, it's dictionaries where the keys are strings and the values are functions themselves. And allow you to, inside sort of these virtualized namespaces, inject functions from other loaded systems, right? Which is how, for example, when you're writing an execution module or you're reading an execution module, you might see dunder salt, right? It's the loader which is going through and ensuring that when this module has been loaded, that you can cross-call other modules, right? So for example, you could create a loader system where, you have your modules and then you could call into the rendering system, right? Or what have you, right? It's the loader that makes all of this possible. When I wrote this talk last year, there were 20-something pluggable systems in Salt. I think it's getting closer to 25 now. Obviously, this is way too many for today. Traditionally, people use, like kind of less than half a dozen and really only deal, primarily with 2 or 3. Because again, most people treat Salt as a configuration management platform. So in terms of pluggable systems, they look at execution modules and then they look at states, all right? Right, okay. So let's start out talking a little bit about beacons. Is there anybody in here who does not know what a beacon is? It's okay. One person, okay, so a couple people don't know what beacons are. Okay, so in order to explain beacons, I want to take kind of a step back and talk about one of the general methodologies of using SALT as a generalized automation framework. SALT, as you've probably heard a number of people talk about, has this idea of an event bus, right? The event bus is just a fancy word for basically a messaging bus. It's a message bus, right? In the same way that we have lots of other message buses that are out in the software development world, right? Be it message queues like RabbitMQ or sort of more complex messaging systems like Kafka, right? It's basically the idea that we can create persistent network connections between machines and that we can pass messages along that bus for those machines to react to and respond to. One of the ways that we think about SALT as a generalized framework is this idea of event-driven infrastructure, right? The idea that we can create relationships between masters and minions, that we can push events across the bus, right? And that we can then react to those events and that we can use those reactions to dynamically reconfigure systems, right? So beacons is a part of that strategy, okay? So simply put, a beacon is a piece of code that you can run. It's a pluggable system, and I'll show you one in just a minute, that runs in the minion on a loop, right? It does a very simple sort of check, and then it may or may not put an event on the bus, right, that can be sent and potentially responded to. So, can everybody see that okay? Do I need to change that to a white background, or are we good? White is better? Yes? Yeah. Okay. Let me see if I can do that. Boop, 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 boop. Built-in schemes. White on black. Ha! That didn't work at all. Yeah. Did I? White on black. Yeah. How about black on white? There we go. Better? Okay. So let me give you an example of how beacons are written. I'll give you a really easy example, something like load.py, all right? So in all of our pluggable systems in SALT, we have a dunder virtual function. Dunder Virtual is used to determine whether or not a particular plugin should be loaded on that particular system, right? Because clearly some plugins maybe use some sort of external or third-party Python library, and maybe that's not available on your system. And if it wasn't, and you tried to run it, obviously it would stack trace everywhere. Okay. So when you're writing a plugin, be it a state module or an execution module or what have you, it's a best practice to include a Dunder Virtual function, right? Dunder Virtual should return either false, right? Or it should return a string, right? Typically something called Dunder Virtual name, right? Which is what it will be called inside the loader. Let me scroll down here. To write a beacon, it's very simple, right? You drop the file here in this beacons directory, and you need to give it a function with the name of beacon, right? And you need to pass that a config. That config will be specified from the beacon, basically the beacon config dictionary in the minion configuration. Here's an example of what that looks like, right? So this, in order to enable this beacon, all you would do is you would drop something similar to this inside your minion config, right? It's basically an options dictionary. And then you basically just write pure Python, right? The point of this being, right, at the end of the day, if you return something from this beacon, it will be put onto the event bus, okay? Right? Does that make sense? So in this case, obviously, we're just like looking at load averages and so on and so forth, and if we're within some sort of threshold, then we fire an event, okay? So probably the next question to ask is, okay, so I've got these beacons, right, and they're firing these events, and that's all fine and good. What can I do with that, right? Is everybody here familiar with the salt reactor, which is sort of like the other side of this paradigm, right? So that's the traditional pairing here, right, is that beacons are firing events, right, indicating sort of the near real-time state of the system. Those events are being fired, and then a reactor can react to them, so on and so forth, right? Any questions about beacons or what they are, what they do, so on and so forth?
How much load does it create for one person?
How much load? Yeah, actually, that's a really good point. As it sits right now, beacons should be as non-blocking as possible. If you block in a beacon, you will block the main minion thread, which is bad. The main minion event loop, I'm sorry, which is bad, right? So beacons should be as lightweight as possible. That is an issue that needs to be fixed, but has not up to this point.
Let's say you have like 1,000 of posts or maybe 100 posts, and you have a beacon that supports speed utilization every minute.
Mm-hmm.
Like, do we need to increase worker threads, for instance?
Mm-hmm.
Or like,
Oh, would you need to increase worker threads to handle that?
Yeah.
I wouldn't anticipate that you would, because the only case where a worker on the upstream or the master side is going to incur some load is if, for example, a reactor matches that, and then some like heavy event or some heavy task gets fired off. Simply the fact that an event is being passed upstream to the master shouldn't really be too much of a concern in terms of load. Yeah, of course. Yes. Sure, sure. Yeah. Yeah, it's really the same answer to the question that was just asked, right? Which is that simply the processing of those events on the master side should be reasonably lightweight, right? It's the question is like, how heavy is the task which is kicked off by the reactor, right? But simply the processing of those events should not be problematic.
But when it's the reactor, I have a reactor
Uh-huh.
to react, at the same time, we will have some indications that, you should indicate how many reactors we have, how many events we have sent back from the indication.
So the question is like, should we worry about how many events are being sent across this bus? All right. To the best of my knowledge, and there may well be exceptions to this, I'm not really familiar with people that are running into that. Thane might be the best person to ask that, because I know that he gets into those types of situations from time to time. I think the question is like, what should they be worried about? The capacity of like the message bus. Yeah.
Or any of the others.
Right.
I'm dug into that.
Yeah.
I've been down there. It's really fast, but I have some concerns
Sure.
that I haven't necessarily come to a conclusion on. So I
Right.
don't want to.
Yeah, yeah. I'm kind of in the same boat. Like I have not come up to anybody. I have not seen any installation at this point that can conclusively put a cap on the number of events which can be passed across a message bus. I'm sure it exists, but I don't know what it is. It's high enough that I haven't seen it in the real world. Please.
Just to contribute to that,
Yeah.
we have pretty good installation.
Yeah.
I think the bottleneck there is going to be the workers processing the requests coming in
Sure.
from the minion to fire the event on the event bus.
Right.
The event bus itself is going to be super fast, but it's
Right.
going to be the workers processing those requests.
Right. But, again, like, so long as they're not matching, right, like they're not matching and kicking off some task, right, even that processing, I think, is going to be pretty fast.
Yeah, I mean, once you get to a certain scale, right? Because
Sure.
it's still crypto.
Yeah. Yo, no, absolutely, right, yeah, you're absolutely right. Yeah, fair point, yeah. Any other questions, concerns? No? Okay. Nope. We gonna go forward or no? Hello? There we go, okay. We went all the way forward. Okay. I think that's where we wanted to be. Great, okay. SDB, okay. SDB, I am sort of anticipating that not as many people are familiar with what SDB is, right? Yes, no? How many people have like seen SDB or know what it is or have used it? Wow, that's actually way more than I thought. So SDB is basically a small persistent data store that can be used inside Salt, traditionally inside Salt states. It's, just like we say here, used for small bits of data that need to persist but don't require a bunch of overhead. And the really nice thing here is that, you can use it just like any other execution module. It's, SDB set, SDB get, right? Basically, you're done, right? In fact, we'll look at SDB right here, right? So this is really straightforward, right? You can configure SDB, right, to basically pull out of, whatever sort of external data store you want, whether it's, memcache or local or, whatever you need it to be. And, really just like the config says, right, set, get, delete, so on and so forth, right? So one of the places that, that people tend to get confused or have questions about would be, things like, okay, how do I write, or how do I have a, state which potentially, does X, Y, and Z, but then, later on at some point in time, I need to write a state, right, which understands the results, of the previous state or, what the state of the system was at that point, so on and so forth, right? So sort of like tracking those, transient bits of data between state runs is one potential use for SDB. People use it for all kinds of things. Does anybody have like a really good use case of SDB that they want to share? Yeah.
Well, in our case, we just use SDB to keep track of stable system.
Mhm.
So instead of returners, they just not convenient for us. In our case, we can like let's say that was something,
Right. Yeah.
The mounted version, something like that.
Right, that's a really common use case is the idea, because right now, like we have the typical, Salt job cache, right? And we store basically what, the results of the job specifically. But sometimes you maybe want to store like external metadata, right, about that job, and SDB is,
Metastate because
yeah, a metastate is,
job is just some simple thing.
right, yeah, yeah. So like storing metadata about a job, right, as it progresses or, sort of like post-job is a wonderful use case. Yeah, Jason?
I've been thinking about putting up the Hackathon wall
Mm.
for management.
Yeah.
Is that the right system?
It depends on, yeah, I would look at it. Yeah, I think it could be good because, like, I mean, you're just concerns about gets and sets, right? Like, yeah, perfect system for that, I think. Yeah, yeah, Eric.
I had been talking to someone the other day about using it in place of Pillar
Yeah.
for performance, so that the meeting doesn't have to wait on the master to compile and then send the data over.
Right.
We're talking about, increasing the speed of something like SDB as an alternative.
Right. Yeah, I think that's a really wonderful use case because, like pillar retrieval is exceedingly expensive, right? And
It was the same situation where we moved away from pillars because we want to use encrypted storage plus the pillars that we're using right now we cannot rely on minion names, so we cannot filter our data in pillar by minion names, so we
right.
ended up putting all the configuration from pillar to
Yeah.
each minion and
Right.
that's not good.
Yeah, and like not to go completely crazy, but I would totally love to see like a pull request for like encrypted SDB because I think a lot of people would find that really useful.
There's already a for instance.
Yeah. And if you want to use like a third-party system, but I would like to do it natively. I think that would be very cool.
Console.
Yeah. Right. Please.
So is the SDB, is that like the master has it and all the minions can get at that data, or is it?
No. This is think of it exactly as a data store which is called via an execution module, right, on the minion. So the execution module is your hook in and out, right, and then you configure the actual data store itself, right, in the minion config, right, for SDB to actually be pulling from, right. Yeah, make sense. Cool. Okay. Hilarious. I love how that just like freezes. Okay. So this is, this session is kind of way too short, but I really want to talk a little bit about this because many people know, like everyone, nobody in here doesn't know test.ping, right? Everybody knows test.ping. It's like our hello world, right? But I think that for anybody trying to learn configuration management, specifically Salt's configuration management, one of the most challenging problems that's out there is how do you understand the requisite system, right? We all know what I mean when I'm talking about requisites, right? This is like, requires and all of this stuff, right? And what I see way too often is people learning this by like destroying, their laptop or, because that's easy to do. But very few people understand that we actually, in addition to having a test execution module, which does many fun things like, Fibonacci and all sorts of stuff, we actually have a test state which you can use to model requisites, right? Let me show it to you because it's really cool. Oops. Okay? You'll be so happy that you've discovered this, trust me. Actually, did anybody here know that this existed prior to me showing it to them? Like a couple, like not very many people. It freaks me out that nobody knows about this. So this does exactly the sort of thing that you would think it would do, right? Stuff like test.noop, test.succeed with changes. And by the way, there are certain cases, right, where when you're writing states, you actually need like a no-op, right, to happen. And like, you know this case if you've run into it before. You can use the test state to accomplish that. Test.succeed with changes. Like, I don't need to read through these, right? It's completely obvious. Fail without changes, so on and so forth. And so, in one hand, like it's nice, and you can just create states to use these. But the nice thing is that you can actually model out what the effect of various requisites are going to be before something really surprising happens, right? So I really like the idea that that you can sort of create like a shadow, infrastructure that, just uses this test state, and then you can start to fail stuff, right? And go, oh, okay, I failed my memcache deployment, right? Like, let's actually do this, fake state run and find out exactly what else is going to fail to deploy. Because anybody who's built like a complex, requisite chain understands that at a certain point, it's really hard to model in your head exactly what's going to happen, especially as you get further and further down these chains. There's tons of stuff in here. I mean, like, clearly I'm not going to, waste your time and just, make you walk through all of it. But, you use it just like you would any other state, right? So it's exceedingly handy. And it,
But we're also using it as a simple replacement for returners. So, like, using Paperclient for Salt,
Mhm.
we don't want to bother setting up returners with some external database or server, so we just
Mhm.
doing succeed without changes.
Right.
Some
Uh-huh.
URL here, there in
Mhm.
data and consuming it.
Right.
Parsing the output.
Right.
Purpose.
Right. So very few people know that that Salt has a queuing system, right? That's built in. It's built around the execution module layer, right? And you can actually interface with it. We have a queue runner, and so this can get really nice, especially like I don't know. Sometimes I feel like I don't need to explain the use cases because everyone in here should be like, oh, I need to build a queue, right? You can do all that stuff in Salt. It's really easy, I'm going to skip over that because we're kind of running short on time. Master tops, right? I actually, every time I come to SaltConf, I get at least like 10 variations of the same question, right? Which is like, okay, I've kind of got myself in over my head about how to like make everything else dynamic, right? But I've got these very static, structured top files, right? And it's hard for my teams to sort of, come together and collaborate on these. One of the things that you can do, we have this master top system, and it does effectively, what we're saying here, which is that you can use, instead of like just declaring these, in flat files, which is what 99% of people do, you can use an external system, and you can query that and use it to dynamically generate, your top file data. We all know what top files do, right? Like they create, targeting data for high states, right? And this is a really important point because this is one of those pluggable systems where most of the time we get like a contribution for something to master tops that's kind of genericized from somebody's like use case, and they're just like, this is generic enough that I'm going to contribute it upstream. So you can use the master top systems that we ship. I think we have a database one, a couple other ones. But 9 times out of 10, this is something where somebody builds, their own system to, do queries in exactly the way they want to do them, so on and so forth. Yeah.
You use an external source and generate your top files that way. Is that still run the maintenance process? How often does that file?
It runs whenever the top file would normally be accessed.
Oh, okay. So it's on.
Correct. It is on demand. Yeah. Is that pluggable with Pillar?
Yeah.
I believe so. I would want to go back and double check. It's been a long time since I've read that code, but I'm pretty sure, let me think. Yes, it should be. Yes. Any other questions about master tops? Sorry. I'm intending to just give a very brief overview instead of diving too deeply into something. Please, if you have like specific questions, stop me and we will dive, right? Okay, so actually, now that I say like I'm going quickly, like I kind of run out of content. One of the things that I wanted to do before I do this, before I just kind of open it up to generalized questions, is to show you the loader, because I would like us to build a number of additional pluggable systems. And this is one of the places where a lot of people like kind of fall over when it comes to contributing to SALT. Like, we're all really good at going, oh, okay, I know how to build a new returner, or I know how to build a new whatever it is, right? But a lot of times, if you have an idea for a new pluggable system, and frankly, like, it would be very easy to build a pluggable system as a part of your deployment, right? Like, if we don't have some sort of clean system for you already, it should be really easy to modify the loader and to call into that. One of the things that's on our list to do is to make the loader itself pluggable, so that like you can extend that. I just haven't gotten around to it. So what I want to do here is give you an example. If like you like computers at all, and I know some of you do, you should totally read this code, because this is like some of my favorite code in SALT. It's really fantastic. It's really, really good, I think. I mean, let's look at outputters, for example, okay? So, if somewhere in SALT, right, you want a dictionary of outputters, right, so that, let's say you need it for whatever reason, you're writing it in your execution module, and you decided that you need that, whatever, right? I'm coming up with silly examples. You call, salt.loader.outputters, and you pass in ops, right? We all know what ops is. It's the option dictionary. It's basically a dictionary that represents the options in your configuration file, plus maybe a small handful of running options. Okay. This is all you need to do to create a new pluggable system. Literally, like, you call it a lazy loader, right, which is this big gnarly class that's above this. It's actually not that gnarly. It's really beautiful code. And you give it an argument of some module ders, right? You pass the function module ders in. Again, you give it ops, right? You tell it what you want, what directories you want to search, right? And you can optionally give it additional like external directories. This is stuff that like normally gets served out of like serve salt. So if you have like serve salt, underscore grains or what have you. Then you pass the lazy loader a copy of ops, right? And you give it a tag for the lazy loader to represent internally what your pluggable system is, right? Basically, you're done at that point. All you have to do is return that, and then you can call, salt.loader.outputters, right, or salt.loader or whatever your new pluggable system is, and you're completely off to the races, right? And you can start to build your own systems around that, and you can use SALT as a framework to do that. I'm going to find another better example, because what you can also do is you can pass in what we call packs, right? Which is the ability for us to like pack in another pluggable system, right? So you could, for example, pass in the SALT functions dictionary, right? And then inside your pluggable system, you can cross-call into dunder salt, and then you have access to all the execution modules, so on and so forth, right? Oops, excuse me. You see an example, actually, of that happening right there inside the auth pluggable system. So I won't get too heavy into that, but only to stress that that building your own pluggable system inside SALT is extremely trivial. It's literally, basically, a line of code, effectively, right? Inside a function declared here in loader.py, and you're done, right? Yeah?
So is there a difference between building a pluggable system that runs on the minion versus the master, and as far as loader.py?
Not as far as loader.py is concerned. It's no. Yeah. Any other questions, either about the loader? We have just like a minute or two, just about the loader, or any other questions about SALT that you would like to have answered or discussed? If not, I will give you a couple extra minutes to go have some coffee and enjoy yourself. And please come up and ask any questions that you like. And thank you for coming by.